Welcome to the 24th Annual Capital Conference Virtual Edition. It's our goal that each of our conference sessions will be about an hour in length, although in some cases we might go a little longer, a little shorter, depending on how the session goes and how many questions we have. This session is Mathematics, a curriculum-driven contest about our high school mathematics contest presented by Larry White, our state contest director. And thank you, Larry, for being willing to share your time and your knowledge and expertise with our attendees at our virtual Capital Conference. And I will now turn it over to you.
Thank you, David. I don't know if any of y'all can see me because I can't see me back on my screen. I'm trying this with an iPad instead of a laptop that I did my last session in, but hopefully you can see me. We'll move on, and I'll be jumping around to different screens as we go along. We're going to do a little discussion on the math test contest itself, and then if there's any time at the end for questions, I'll try to answer what I can. Those of you who want to have problems solved, we probably won't have time to solve too many problems today, but we're going to be doing a problem solving session, I believe, on July 10th. So you can email me or David the problems you want me to look at in number sense or mathematics, and we'll try to solve some of those on that July 10th meeting. So bear with me, and I'm going to see if we can move over and bring up my presentation. Hopefully everybody can see that. David, can you see that? I guess I can.
Yes, we can.
All right, good deal. This is the session we're going to do for mathematics. The math contest is a curriculum-driven contest. By that I mean it actually comes directly from your curriculum. All the ideas used with TEA and all the requirements are all part of this contest. So it's actually a testing over what you're supposed to be teaching school curriculum. It's the reason we call it a high school curriculum-driven test. For those of you that don't know me, my name's Larry White, and this will be my 19th year to be the mathematics contest director. You'll see that email right there. I encourage you to have a copy of that, and so that you can contact me throughout the year if you have any questions about anything, or if you need assistance in helping set up your program, or if your kids have any questions and you can't answer them and you need my help, you can email me. The kids can't, but you can. So it's a valuable email to have. This other thing down here, this is the UIL website. I'm going to jump over that in just a second, so if you'll bear with me just a second. This is what the website looks like. If you'll go to academics and then go to STEM and then go to mathematics, you'll end up on my math page. This is the page where I'm able to contact you throughout the year with any comments or suggestions or anything I want everybody to know. And if you'll go down here on the right-hand side, you'll see these correction pages. This is the page where I actually go in and I tell you what I want you to know throughout the year, so that you don't have to wait until next summer when I report something. And this tells you if there's a mistake on a key or any discussions we might have. So this is a real valuable way for me to talk with y'all. And I think there's 3 sets on there. We will start 2020 correction sections later on as we get closer to the fall when we go along. So let's go back to the presentation. Come back here. Here we go. And we'll just start moving on. The mathematics contest, for those of you that are newbies or relatively new, is a 60 multiple choice test. There's 5 answers. All of them are answers. There's none of these things. Supposedly, if I'm doing my job correctly, the correct answer should be on the test, if I'm doing my job right. It's a 40-minute test. You can use calculators. We'll talk more about calculators later. You can use scratch paper. You can write all over the test. What you just don't want to write on the answer sheet except for the capital letters of the answers you want. The problems are not in specific order. They range all over the place. And, they just don't come in any particular order. The scoring is 6 points for correct, 2 points off for incorrect. If you skip, it is not counted against you, whereas in number sense, it is counted against you when it's skipped. But in mathematics, it's not. So you can skip all you like. If you get problem correct, you'll get 6 points. If you put an answer down and get it wrong, you lose 2 points. If you leave it blank, nothing happens. The grading and scoring is found in the 2021 UIL Mathematics Handbook. You ought to be able to download that from the UIL store so that you'll always know what the rules are. If you contact me at district or regional about a rule violation, I will take you straight to that mathematics handbook, and that's where the decision will be made from. The contest itself is written. This is my way I write this test. I have problems from basic mathematics, about 6 or 7, and then I have 6 or 7 algebra 1 and 6 or 7 geometry and 6 or 7 algebra 2, and so on down the line, trigonometry, analysis, basic calculus, probability, and then my all-time miscellaneous favorite section that I create. A lot of people consider trigonometry and analysis as being pre-calculus. I just break it up into 2 parts for a particular reason. And then my favorite section is designed to get you and the students a chance to look for new things that may not be in your curriculum. And I'll talk a little more about that as we go along. Here are some of the ideas that I used last year on the basic math problems. Problems like order of operations, consumer mathematics, set theory, percents, fractions, decimals, measurements. It's all those sort of junior high on down math concepts that everyone should know. And so I always consider those as basic math. Here are some examples. I don't know if you can see that. Oops, excuse me. I just marked on my paper. I'm not real sure how well you can see that, so I'll make them a little bigger. But there's an order of operation problem there at the top, and then there's a consumer math problem there, and then there's a sort of measurement type problem there. These are similar to the type problems that are in the basic math questions. By the way, all these questions came off of last year's student activity conference math test that I write, and you'll be able to download that when I submit them to David after this session's over. But those are some examples of what they look like, and you'll notice that there's always an answer. There's not a none of these. So that supposedly the correct answer is there if I didn't make a mistake. In Algebra 1, some of the ideas that I've used past and sort of familiar with are dealing with graphs, slopes, intercepts, plotting points, that kind of things. Polynomials, multiplying, dividing, factoring, application of using algebraic topics in everyday life. Those are all pretty good things for me to use on the test. Here are some examples of some of the problems from last year. And you can see there's a factoring problem up there, and then there's a slope problem, and then there's an application problem. And like I say, these are the type of problems that you can depend on seeing in the context. In geometry, drawings, and I find that drawing section rather interesting because sometimes I do the drawing, sometimes I write it out, and the students have to do the drawing, be able to translate from text to pictures. So drawings is an interesting thing. Theorems and axioms are a lot on there. Using geometry in everyday life for applications. Transformations, moving objects around in different ways. Anything dealing with polygons and polyhedrons are on there. And here are some examples. There's one on the supplementary angles. And then there's the perimeter of a hexagon using the knowledge about 30, 60, 90-degree triangles and 45, 45-degree triangles, right triangles. And then so on down the line. It's different type of problems that you will see using geometry. In Algebra 2, we start getting into roots of equations, solving and creating and analyzing all sorts of equations, dealing with functions and their graphs, especially parent functions and how they get affected, applications of Algebra 2 topics, sequences and series, exponents and logarithms. And keep in mind, all these lists I'm giving you are just partial lists. Anything in the Algebra 2 curriculum, anything in your Algebra 2 textbook is available for me to ask a question on. I'm just giving you some sort of highlights of some things I've done in the past. Here are some examples of such. This is a rather interesting problem right here, because not only is it a nice root problem, it also happens to be a number sense trick on how to find the sum of the root squared, because you see this right up here happens to be r plus s squared, which is the sum of the roots squared. And if you happen to know the number sense strategy for finding the sum of the roots squared, then you can actually figure that problem out very, very quickly. So it makes it real nice. And then there's just some other problems on there where you can look at and see how they work. Okay, let's go. Okay, in trigonometry, once again, we have drawings, and it's both ways. Sometimes I make the drawings, sometimes I ask the students to make the drawings and be able to work the problem from there. Application in using trigonometry, all the wonderful graphs of trigonometry, bearings in courses, and then of course, identities and things like that. And then we have, there's some examples here, things that are going on. You can see that they're just different problems. I made the drawing on this one, but I'm liable to have a statement and they'll have to end up making the drawing. So it just depends on what type of question I write. In analysis, we have patterns, all sorts of different types of patterns. Bases that the students are responsible for, as far as I'm concerned, are base 2 through 10, and 12 and 16 are the ones that I really concentrate on, but any base can happen. As it turns out, whatever you can do with in base 10, you can do in any base. And so I tend to do a lot of that stuff. Applications and analysis, we use different things. And statistics. I just started getting into statistics pretty heavy last year, and we'll do statistics again this year. then we'll see some samples of such things. Here's examples of, there's a matrix determinant, and then there's a pattern there, and then you have progressions. So these type of things are examples of what comes out of pre-calc or analysis. Then we have calculus, derivatives and antiderivatives, integration, application, max, mins, reflections. All those calculus items that you had in your calculus book are all up for grabs. And these are where some of the things that I work on. And here's some samples, some examples that you'll be able to look at. And this is one of my favorite ones right here, because derivatives are really relatively simple to do. You can teach a young person, even if they hadn't had a whole lot of calculus, how to do a derivative without having any real thought process. However, if I reverse that and give you this information and you have to go find everything, I can reverse that and give you I can give you what this is, and I can give you what that is, and I can ask you what that is. And so I can reverse it, and that shows that the kids have a better understanding of derivatives other than just doing the very computational derivative. Okay. Probability, sample spaces, probability, odds. Probability does not get covered very well in curriculum. It should be. It's in every math book that was written. We don't do a lot of it because it's always towards the end of the year in the textbook. I caution you to consider introducing probability into your curriculum earlier and during different stages. Not all at one time, perhaps, but keep bringing in probability. I think it's a very powerful concept we're missing out on. Combinations, permutations, factorials, arrangements. And I also tell you this, probability is one of the most difficult concepts for anybody to understand. They can get really deep and get to be very difficult to handle. And here's some examples of some of the probabilities. Now, I'd like to apologize for using names like that. But I really won't. I like my names on my word problems. I like to make them up. They're humorous. The kids sort of get relaxed with them and enjoy them. So you'll see these crazy little words. I like to do them, so it's okay that you can see those. And I know we're going through these questions very fast, but like I say, you'll be able to download the SAC test from last year and be able to see these exact questions because that's where they came from. Oh, I'm sorry. Yeah, okay. This is my favorite section. And I call it my favorite section because I have to work, I go looking for special things that students may not be able to see in their normal curriculum, but I think it'd be interesting for them to know. For example, several years ago, I brought in mathematicians and I asked students to know what mathematicians contributed to the world of mathematics. I don't care anything about them knowing who their second cousin was. I want to know what they did for mathematics. And then I brought in several years ago special types of numbers. Everybody thought I was making these up, but there are numbers like evil numbers and odious numbers and happy numbers and unhappy numbers, all based on mathematics. So I thought I'd bring those in so that students could sort of see that there's more out there than just what's in their textbook. Special sequences, especially Fibonacci. I've been studying the Fibonacci sequence for a little over 40 years. I find it fascinating, and so I like to bring new things I learned from Fibonacci. Special drawings, base manipulations where you manipulate one base to another base and so on. and then some unique challenges that I come across for them to play with. So they're able to do some extra things. And you get to see all this stuff during your practice tests before district, regional, state. And that gives you the kids time to get on the internet and do some research and stuff. So it works out really nice. Here's some examples. Here's what are some of the first 5 positive evil numbers? And evil numbers do exist. There's a mathematical reasoning behind it. And then we have add and subtract bases. And then we have a standard deviation problem. And that's one part of the statistics that I'm coming in. So these are some problems, similar problems that we see. Okay. Now, at the end of the student activity conference test that I write every year, you will find a list of the mathematicians that the students are required to be aware of if they want to get that problem correct. It's an easy 6 points if they've done their work. These are the mathematicians that I have chosen over the years, and once again, it's not what Archimedes' second cousin's name is. It's all about what was Archimedes' main contribution to mathematics. That's what I'm looking for. Several coaches have told me they've had their math kids create one-page bibliographies of each of these people and then post them in the classroom for all the kids to see how the mathematicians, how all this came about, and it just wasn't just made up out of a textbook. So these are pretty neat to have. And then this is the list of the special numbers special types of numbers. Of course, some of them everybody already knows, the complex numbers and transcendentals and rationals and irrationals. But then you get along around there and you start seeing numbers like vampire numbers and harmonic numbers and wasteful numbers. These numbers, these aren't made up. They're actually very true, and each one of them have a mathematical basis that makes them the way they are. And these will be at the end of the SAC test as well. When you download the SAC test off of the website, when this is through, you'll be able to get this and see all of these things. And then the SAC test that I've written for this year will have all these at the end of the SAC test as well, for you to find them. So basically, that's what the test is constructed and put together, and it'll give you sort of an idea, for those of you that are new, how all this works. There again, the real key is this is all about curriculum. You know, if you have a good school curriculum, your kids can be able to compete just from their mathematical knowledge of the curriculum, because that's where this comes from. Now, as far as calculators are concerned, this is the rule that governs calculators. As long as it does not require auxiliary electric power, as long as the calculator is not modified, and you can't hardly modify calculators anymore. It used to be you could, but you can't modify them anymore. They have to be handheld and silent. And they have to be sold as a calculator, and that can't be a mini computer or anything like that. It has to be sold as a calculator. I don't know of any calculator in the market today that I'm aware of. I keep up with this pretty well. That the calculator is not usable. The latest issue was the TI Inspire. The TI Inspire fits all of these categories as long as you don't put the little hat on top where they can do the internet and transfer data. That's called a modification. So TI Inspires are perfectly fine to use if that's what you want them to use. I suggest that kids always have a scientific calculator and a graphing calculator. They can have two on their desk when they're taking the test. Those are my suggestions of having those two. We do not clear the memory. whatever they put in there, if they want to program, whatever they want to do, that's their business. We don't clear the memory. We just let them use their calculators. I usually have a pretty good idea what they're programming and what they're not programming, and I try to make sure that the calculator doesn't take power of the test. And in fact, the people that usually make it to win the championships and get in the top 6 or whatever, they never use the calculator on the math test more than 10 problems. Most of them don't even use it for 5 problems because the calculator slows them down. They learn things to do without the calculator. But it's available. I think calculators are fantastic if they're used properly. And I encourage teachers to teach their kids how to use, when to use it correctly, when not to use it correctly. Because in a 40-minute test, if you use it too many times, you are way, way far behind. So let them use them, but teach them how to do them correctly. Okay, resources. There are not really a lot of resources out there as far as, how to solve problems and stuff like that, because it comes out of your curriculum. That's the best resource. But we have some other types of resources like Texas Math Science Coaches Association, where you can they have some resources. They have practice tests. They have competitions, the big state meet in San Antonio in March, where the seniors compete for big scholarships. This is a wonderful organization. You can take your team to the state meet in March for TMSEA as long as you're a member. And I think the membership fee for a school is like $50. I don't know for sure, but I think that's right. They also have a junior high meet in April, and it's rather interesting, but the kids have to qualify to go to that. And there'll be sometimes 1,500 kids qualify, middle school. So it's pretty impressive. So anyways, if you need more information on Julie and the Texas Math Science Coaches Association, be sure that you contact her by phone or email, and she can help you with the information. Very, very good resource for you as we move along. Books, the best, there again, the best resource is a good mathematics program. The high school curriculum textbooks, I mean, that's where most everything comes from. Don Scow was math director before myself. He has a little bit of stuff. And then Leo Ramirez has a lot of material for number sense math and calculator. Leo was the Disney Disney Teacher of the Year many years ago when they first began that. He's pretty good fella. Websites, you can go to UIL website to get lots of information and tests and resources, and of course TMSEA. And then if you're into virtual meets where school can't travel and stuff like that, you can get a hold of Chuck Thompson at the virtualchallengemeets.com. They do a lot of virtual competitions where the kids can compete at home and against the rest of the state. So it's a pretty nice thing to get involved to. Get a hold of Chuck and see what he has to say. Practice tests, you can get practice tests from UIL, TMSEA, Leo Ramirez and the Rams. Andy Zapata has practice material. For those of you who don't know, Andy Zapata is the middle school math contest director. And so he has information, and you can get a hold of Andy at that information as well. Let's see. Okay. Practice tips and whatever. If you don't learn anything from what I'm telling you today, than anything else, if you want to get good at the math contest, the success comes from knowledge, not from time test taking. I don't know of many kids in any school that have 40 free minutes every day to take a time test. Most kids barely have 40 minutes to do their homework. there's not enough time in class. They have extracurricular activities, athletics, when they play band, whatever. They just don't have time. They have chores. They want to spend some time with their family. It's hard to take a time test in mathematics. So if you want to get fast and get better, the key is to have more knowledge. I coached mathematics for many, many, many years. Never did any of my students ever take a time test except at a competition. They just don't have the 40 minutes. They need to be able to work a problem between commercials with their favorite TV show, or work a problem with the last 5 minutes of English class, or wherever they can steal a chance to work a problem. And then when you meet with them as coaches, you certainly don't want to spend your time watching them take a math test. You want to spend your time working with them, solving problems that they don't have. So it's a pretty good. But as they go through the test, there's a nice strategy, or at least my philosophy is. I will also post on the UI website some hints that I used as an ex-coach that might help you, the beginners, might help you as you prepare your team. One of the things I always had my kids do was to take a math test and not work the problem, just to go through and put a QH next to the number that they think is a quick hitter. And of course, quick hitters are normally single line questions. You know, they're what we call quick hitters. You can do it. It doesn't take long to read it. You can solve it and move on if you have the knowledge. If you don't have the knowledge, well, it doesn't do you any good. But they're considered quick hitters. Here's another quick hitter. And it's a quick hitter mainly because kids love to do picture problems. They'll look at those automatically, and so they can call that a quick hitter. And they go through and they find out how many quick hitters there are in a test.
No, bring those now, but I'm printing as he's going. Okay. Thank you.
Hello? Oh, I'm sorry. I thought I heard something back there. Anyways, these are sort of like quick hitters. Then they need to go through and put some DOs along the deals. And doables are problems that they can probably do, but they're long. You have to read them. Their word problems are usually get into the doable category. And so they put the DO, and what you do with doables is they come back to them later on after they've done some of the faster stuff first. So doables become easy to mark. Number sets, you have to understand that the crazy guy that writes the math test also writes the number sense test, and he really does love number sense. So you will find number sense problems on the math test. So learning to work with your number sense kids, your math kids learn to work with the number sense kids can be a real asset. They don't have to compete in number sense, but learning some of the number sense tricks is very valuable. And of course, these are both quick hitters, especially because if you know the number sense trick, each of those problems probably wouldn't take more time writing down the answer than it would take to solve it. So you look for the number sense tricks. And then you go through and you find the calculators. And this is the one crucial to me. You put a letter C on next to the number if you think it's a calculator. And coaches, if you'll look at the kids when they write these things down and put the C's down, you'll see that they're putting lots of C's down. And that's when you have to take the time to tell them, wait a minute, this is really not a calculator. You just think it is. Let me show you why it's not a calculator. And now this particular one, 30 months at 2.5%, compounded monthly, this is a calculator problem. And you put a big C over there so that you can use calculator. But if the students start finding more than 10 calculator problems on a test, then they're not using their calculator efficiently, because I try to avoid that problem as much as I possibly can. I want them to use the calculators when it's appropriate. Okay, again, tips. If you want to speed up, get some more knowledge, learn some more things. You can't solve a problem if you don't know what the problem is about. If you want to be successful, you got to work more problems. The more problems you work, the more you know, the faster you will be. It's just the way it is. With all that in mind, that's a rough run through of the mathematics contest. I think it's a wonderful contest, not only just for UIL. I used to give my advanced math classes a mathematics test as they'd have to work 2 of them every 6 weeks, and that was part of the test grade, because there's so many neat things in there that they may not remember from years back, that they get to go in there and try, and it sort of brings mathematics all into one. We take kids into pre-cal, for example, and they think everything in there is just called pre-cal, but it ties in algebra, it ties in geometry, it ties in trigonometry. Everything gets tied into the contest. So I think it's a very valuable contest to have all your kids work on and do. I think it's a very appropriate thing to have. And there's some really, really great problems. I work really hard to try to bring in problems that will teach the kids new strategies and help them to learn. Because when it's all said and done, we love UIL, we love to go to state, we love to have state champions, we love all those kind of things. But what we really want to do, we want to know that our children are going off in the world with a good mathematical background so they can be great assets to our country that we need so valuable. So with that, I'm going to say an apple a day is good for your health, and a math problem a day is good for your mind. And I'll stop at this point, and if David has any questions, then we will answer those questions. And I remind you that if you solve some of these problems or you have some other problems you want me to address, you need to email them to me. I will make a list of them, and we will discuss them on, I believe, July 10th in my next session, where we're going to actually just solve problems.
All right, thank you, Larry. We've had a couple of questions get entered in the chat box that I've been able to answer with posting links where to find information about the middle school mathematics test, and also where the SAC tests get posted, and how folks can find that information. We did have a question from Jimmy just asking, will there be any student activities conferences this year? And we certainly hope so. We don't know for sure yet. Of course, the colleges and universities where we have those conferences have a lot of restrictions in place now in terms of how their classrooms and other facilities can be used. And so we're not sure if we'll be able to have in-person events, but if not, we'll certainly look at a virtual format like this for a student activities conference. So in some form or fashion, we do plan to have conferences. We just don't know if in-person events are going to be possible this fall.
I've already written the test, just haven't been submitted yet. And I'm already working on what happens if we have to do this by Zoom. So we'll be prepared whichever way we go. I hope we can see each other face to face. I miss seeing all those eyeballs. I never turn my back on my children, and when I'm working with coaches and kids, I want to see their faces and hear their oohs and ahs. And sitting here in this office of mine and looking at the wall is not my cup of tea, but we're going to do what we can to help the kids and the coaches with UIL.
There was also a question about recordings, and specifically the problem-solving session on July 10th. We will record that one as well, and that will be posted on our video archive. So every session of the conference will be recorded and posted later on in the summer. And there was also a question, Larry, do you have any particular tips for younger students, for middle school students in preparing for mathematics?
The middle school contest, Andy and I work pretty close together. He tries to take some of the more basic concepts that I use in algebra and geometry and basic math, and at a much lower level, but he sort of introduces problems that they will lead into into what problems I write. So yeah, my suggestion is the kids, once again, the best thing to do is get a hold of some old math tests, some practice tests. UIL has them, Andy has them, and just have kids start going through those test questions. The wonderful thing about that idea is if a kid is looking, if you give a class the front page of a junior high math test and have the kids look at it and say, which of these can you not do? It's not, it's really not important what they can do. It's which of these they can't do. And you will find out that a majority of them can't do a particular type of problem. And you can spend some time working with that problem instead of going over the whole test, which they can already do some. So I suggest that you give your kids a test or a front one page at a time and just start to find out what can you do and what can you not do. And have them just mark on there, okay, no, and then turn that page back into you as a coach. And then you can look at that and see if there's any consistencies. And if you find out they're having trouble changing fractions to a percent, that's a concept that they're weak in, and you can spend some time working on that concept. There's no sense in working on adding two numbers if they can all add. So that's how I used to find out where my kids' weaknesses were. I do it in high school as well. I would give them one page, and then I'd give them another page, and then they'd go through there and mark them. I didn't want them to work the problems. I was trying to find out what they knew, what they didn't know, so that I could concentrate on those things. So that, to me, that's one suggestion you do. You could even send it home with them and tell them, hey, go through here and just mark, yes, I can do this. No, I can't do this. No. Have them circle any vocabulary. That's real important. Have them circle whatever vocabulary they don't understand. They may see a word and they can't solve the problem if they don't know what the problem is asking for. So have them circle vocabulary that they need to know. Those are some ideas, and I'll post some other ideas for high school, which actually can be used in middle school as well. And then if you have any direct questions or concerns, whatever, feel free to email me. We'll go one-on-one, and I'll try to help you with some hints to get kids active in doing this.
All right. Do we have any other questions? If you have any other questions, go ahead and put those in the chat box. We will have, as Larry said, we'll have new SAC tests for mathematics and for number sense that'll get posted this fall, and we'll see what our conference format looks like as to how and when that happens. But those will be available. I'm not seeing any other questions pop up, so if there are no further questions, of course you can, as Larry said, you can get in touch with him. Oh, here we have one. How much time is recommended for students to look at questions when they're beginning to work on the test? I guess to go through it and look at the types of problems and decide.
It's not about speed. It's about understanding. They need to take the time to read the problem, think about it. Oh, I can do this. And if they have a question or not, I think I can do it, but I'm not sure. They need to put a question mark on there. We tend to do too much time spending on speed. It's not important to be fast reading questions. it's important to be able to read it and decide, should I spend the time on this? Should I not spend the time on this? If I can't do it and I don't understand it, I should know real quickly. If I think I can do it, but I'm not sure, then it becomes a questionable, and they probably need to come to you to see if there's a quicker strategy. Yeah, so it's not all about how much time I should give them. That's why I said perhaps you send a sheet of paper home, the front page home with them, and say, hey, look these over and put down, I can do it, it's too slow, I can't do it, I'm not sure. Mark it wherever they can. It gives you, the coach, the teacher, the opportunity to know where the weaknesses are. If you want to really have a real good time, take your 8th grade class, math class, or 7th grade math class, and give them this sheet, the whole class, and let them take it home and come back. You can find out where your class is weak and where they're strong. And that might change what you're teaching in the classroom. Instead of spending a lot of time on something they already know, spending time on stuff they don't know. So it's a good strategy for that as well. So don't be too concerned about speed. It's all about knowledge and confidence and knowing what they're doing.
All right, I think that gets us through all of our questions that we have. So if there are no further questions, we'll go ahead and wrap up. Thank you again to everyone for attending today. We have, for those of you who work with calculator applications, or oh, we have another question that's just come in. How do you handle the vast differences in abilities, students working at different levels of their ability in mathematics?
That is always a challenge. Now keep in mind, there are always a good number of freshmen at the state meet. They get there because of this team concept. Now, there have been a few that actually got there and won the state meet and didn't need a team. But for the most part, the freshmen and young kids get there because they contribute to the team. Now, and the interesting thing is there, when I write a math test, I try to always make sure that there's at least 20 problems on the test that any freshman who's been through Algebra 1 and a little bit of geometry can solve. So if a student can go in there and find those 20 problems, they can contribute to their team and make it all the way through. And so it's not about them learning everything. Get them good at 20, 25 problems. And then next year you can add 10 to it. And then the next year, and sooner or later, they become the power mongers as seniors. Don't too many people try to overburden a freshman with calculus. And that is very difficult unless they're a very, very intelligent freshman. So instead of overbearing them, have them search a test to find those things they can do. It goes back to that marking that test again. Find those things that they can do and they can't do, and they should be able to do 20 problems on any test I write, because I intentionally do that. I want freshmen to feel success, and I want seniors to be challenged. So there's a fine line there where they go. So don't let them spend too much time learning a bunch of new stuff that they're not really ready for, even though there are some little short tricks they could learn from some of the advanced problems. The real key is to get them really good at what they can do and then let them branch out. And eventually, one of your students that you've been working with will come across something and say, I don't know anything about that, but I think I'd like to, and they will bring that to you. And of course, the best time to solve that is right when they bring that to you. So yeah, there's a big separation between basic math and calculus and probability. But your young people should be able to pull off at least 20 questions on any math test I've ever written.
All right, I think that's all of our questions. So thank you again, everyone, for attending today. Thank you, Larry, for presenting. We also tomorrow have a session on calculator applications if you work with that contest. Dr. Dave Burrell will be presenting that, focused on scaling problems in that contest. And we have a science session focused on chemistry on Wednesday if you work with the science contest, high school science. So that's what we have coming up this week. Thank you again to everyone for attending today, and thank you again, Larry, and hope you have a great day.
I hope everyone has a great day, and I hope I get to see you all soon and we get our children back to school where they need to be. Have a good day.